All right. Good morning, everyone. Yeah, I've noted the doubt one of you has asked. Don't worry, I'll address all your doubts. I think before that, I'll just start with a quick introduction. I'll just show you my face. Yeah. So yeah, my name is Kevin. Welcome to PACE. I'm going to be your physics teacher. My name is Kevin Daniel, and my code is KJP. And if you're wondering why is there a J in my code, does it stand for something? So actually, the J was a mistake, and I think initially I didn't change it, but now the name has kind of grown on me, and um, now I don't want to change it. I kind of like the name. So, but that's why there's a J in my name. My name though is Kevin Daniel, as you'll get to see whenever the Zoom invite comes to you. I did my bachelor's in mechanical engineering from IIT Bombay, and I passed out of that in 2016. I got in just entering people in. So yeah, I did my bachelor's in mechanical engineering from IIT Bombay. Um, I got in 2012. When I got in, I uh, secured an All India rank of 92 in JEE 2012. So I topped Pune, got a rank of 92. My name came in the newspapers and all of that. It was a nice, really proud moment for my parents. But yeah, then post that, after passing out of IIT, I wanted to teach. So I immediately got into teaching, and I've been teaching ever since. So it's almost close to 4 or 5 years that I've been teaching physics. And I teach NEET students, JEE students. I teach all of them. So you don't need to worry about that. Yeah. So that's a little bit about me. Okay, one more thing I'd like to add about me is, just for you guys to know, I like playing music. So I can play a couple of instruments like the guitar, the keyboard, the drums, the bass, and a few more. And over here to my left, you can still entering some people in. Over here to my left, you can see a collection of my guitars and basses and ukuleles, and yeah, just for you guys to see that. It's always, what I would say is, it's always good to have have one or two hobbies, because especially you guys being medical students, you're going to be studying for the next, I don't know how many, 7, 8 or more years. So it's always healthy to balance a little bit of your time when you're not studying, to use some of that time productively, maybe pursue a hobby as a lifelong goal. Don't try to learn it in 1 year, but as a lifelong goal. And the entire journey will kind of keep you happy. It will also, cause your brain to develop in other areas, and it will also help you um, just relax and be more productive in your pursuit for your medical studies. So it'll be good to pursue hobby. Whatever free time you have, try to avoid. If you consider gaming a hobby, try to cut down on that. I think there are far more um, productive hobbies like music, like arts, dance, or even exercise. Right? So try to make smart choices from now on. That's just my suggestion. That said, I'm gonna this is my lockdown face and beard, hair and beard, so I'm gonna not show too much of that to you. But that said, I'll just go over a bunch of instructions on how we're gonna conduct these classes. Okay. So first and foremost, um, don't worry, you won't have to see my face every time. In fact, we'll try to use technology. Almost all that we do is going to be done by me sharing my screen. So I'll use a couple of apps like this one. Okay? But then that said, here are some instructions. So first and foremost, for your safety, just so that uh, people don't spam the meeting and then disturb you guys, or come up with any weird, irrelevant, obscene messages. What we will do is we won't allow you guys to mute. Okay, we won't allow you guys to unmute and talk and ask doubts. So then how do you ask your doubts in that case? You just type it out in the chat. And I've been teaching students for over a year now. It works smoothly. Whatever doubt you type out, I will address that. You can type out while I'm talking. You don't have to wait for me to finish. You have a doubt, you can type it out. I will address that. Okay, so you don't need to worry about uh, your doubt reaching me. Moreover, whatever messages you send will come only to me. It won't go to anyone else. Okay, so that's a good thing. I mean, you can't disturb each other, and moreover, um, you won't. I mean, you won't feel embarrassed if you think you have an embarrassing doubt. You don't want others to know. You can still ask me. Nobody else is going to see your doubt. All right. The other thing is, I would request all of you to keep your videos off. Okay. I mean, my video is not on, so yours also need not be on. Keep your videos off, but be involved. So if you keep asking me your doubts, I'll know you're like in a way paying attention, you're involved. If you keep answering questions, I'll know that you're benefiting. Vedika, I see your doubt. You're asking about which textbooks to use. I'll get to that in a bit. Don't worry, we'll cover textbooks, we'll cover everything. There are a few more points I need to talk about. So firstly, you, all your doubts will be through the chat. Okay? If there is some doubt you just are not able to express in words, I mean in typing words, then maybe you can raise your hand and I can unmute you and I can ask you the doubt. But even that, let's try to avoid for the initial few weeks. This is when spammers really try their best. It's after a point of time where spammers give up and stop coming to these meetings, because then they realize, okay, I can come to the meeting, but I can't unmute, I can't share anything, I can't rename myself. So yeah, then they give up. So then afterwards we can become a little bit more um, comfortable, and we can allow you guys to at times unmute and ask it out if it's difficult to type it out. So for the first few weeks, we'll try to avoid that. Okay. Now, just some more instructions before we get to physics and textbooks and all of that. Some more instructions. Okay. So I'll actually be teaching you guys on this app called Microsoft OneNote. All right. So I have to kind of locate where vectors is. Just a minute. Just a minute. Yeah. Okay. Yeah. So I'll actually be teaching on this kind of app. And the good thing with this app is all the notes that I'll be making, they'll all be uploaded on the drive. So what I'm going to give you, what I'm going to do for you guys is after class, you're going to get a link. In fact, you're going to get two links. You're going to get two links to two folders in my drive. And if you don't have your Google Drive app on your phone, you can just type Google Drive on your web browser and it'll lead you to your drive. Just log in with your Gmail ID. Okay, and then you can access this drive. So I'll be giving you a link to two folders. So one of the folders is going to be called PACE Lecture Notes. As the name suggests, this is where your notes are going to be. All right. So now if you open the folder, it's going to look like this. You're going to see a bunch of topics. Don't worry about that. The one that is started for you guys is vectors. So, I mean, that's what we're going to start with today. So you'll just open vectors in that case. Now, when you open vectors, you'll find two parts in it. This is, I mean, no specific division. It's just part one ke baad part two aa raha hai. There's no specific point where it gets divided. So, yeah, if you're at the beginning, you know you have to go to part one. Like for today, your notes will be in vectors part one. All right, and all the notes, each individual page is uploaded as a PDF over here. You can just open it on the drive, and you can scroll through the pages. Okay, you can download these pages as well. So this is how it's going to look. You can download them, you can take a printout of them if you want. um, if you do not want to make notes while I'm teaching in class, you can do that. You don't want to make notes, you just want to pay attention and solve sums, you can do that. You want to make notes, some students feel that if they write, that's when they understand. So if you want to make notes, you can do that as well. Okay, but just if you're making notes, just try to be a little fast. As soon as I switch a page, start writing if you want to make notes. So listen and write simultaneously, you know, because we don't want to hold up the entire class. If you're making notes, be fast at that. Otherwise, you can refer to these notes. Um, all right, so that is where the notes are. Okay, again, there's a link which I'll give you for the lecture notes. You open vectors, just remember the name of the chapter. Utna yaad rahega, so you can find your way. Part 1 logically, and then open the notes. That's for the lecture notes. Now, all these meetings that I'll be taking with you guys will be recorded. Okay, so because it will be recorded, you can access the lecture recordings as well if you want to ever go back, or if you miss a lecture, or if you um, maybe lost focus towards the end of some lecture and you want to check that again. All this is recorded. All this will be available on the drive. So I'm not going to give you a link to each recording after class. The problem with those links is those links, I think they expire after the specific amount of time. So it's not on the cloud, this is on the drive. It will never disappear. What you need to do is this folder ka link jo main tumhe dunga, you save that and keep. When you open it, now have a look at this. Again, there are a lot of chapters, but locate your chapter. What is going on? Vectors. So open vectors. So when you open vectors, you're going to see two folders. You know which batch you're in. You're joining in year 2021. Your exam is in 23. This is your batch. Okay. So this also shows that those who I taught last year, all their lectures are still there. So these lectures are never going to disappear. So open 2021, 2023. In that, your batch is going to be Med 1. More batches will be created in some time. Just remember yours is Med 1. Okay. And of course, this is empty because today is our first lecture. But just to show you what the name of the files will look like. All right. So maybe I will use one of the older ones. For instance, the name of the file will look like this. That could be confusing. Vectors 1, and then you'll have the date, and then you'll have your batch name, Med 1, and then KJP.mp4. The reason you have all of this is if you just want, when you open the drive, you can even just search vectors 1, type vectors 1, and in a way lead you to the, and type your batch name. It should lead you to your file. So that's why there are these tags, but otherwise you won't need to do any search. You just have to go to your particular batch and your lectures will keep getting uploaded here. You'll have the date, you'll have the lecture number as well. All right, instructions are clear. Okay, lecture notes, lecture recording ka link mil jayega. Okay, and if you don't know what Google Drive is, just search Google Drive. It'll open on your browser, not a big deal. Log in. Okay? Very useful tool. All right. That said, we will start with vectors. But before we do that, before we start with vectors, let me just give you a little idea of what we have in physics. So physics as such has several subparts. So there's a subpart called as mechanics. You need not note this down. Just for your information, there's a subpart called as mechanics. There's another subpart called as electromagnetism. Okay. So electric fields, magnetic fields, it works with all of that. Then there's another subpart called as optics. Okay. Then you have thermodynamics. You have waves, and you have modern physics. These are the broad categories we'll be digging into over the next 2 years. Now, just to again give you some, a lot of students always ask this, sir, why do we need to study all this? We are trying to become doctors. What use does it have in becoming doctors? The answer is fair enough. Not all of this may be useful for your exact work as a doctor, all right? But as with anything else in life, to become a doctor, you fortunately or unfortunately have to first clear the NEET exam, right? So you don't become a doctor overnight. There are these steps you need to cross. So first step is, of course, clearing the NEET exam. NEET exam, 1/4 of it is physics, which is a big amount. So just to become a doctor, with the desire to become a doctor, with that passion to become a doctor, you need to do well in NEET, and to do well in NEET, you need to be good in physics as well. So let that be your motivation. It's not about how you're going to use this, but to become a doctor in the first place, you will need to clear the NEET and do well in physics. Okay, so always remember that you're doing all of this because you want to become a doctor, you want to get a college of your choice, a field of your choice. That's why you're studying physics, right? All right. Like just to, I mean, even reach here, we had to clear our boards. And in our boards, we wrote history and geography and those kind of papers, which we may not use again in our lives. But I mean, that's how things work. We had to clear our 10th. We had to study those subjects. We're done with it now. We need not go back to it, but we had to clear that. Similarly, you need to do well in NEET, and therefore you have your physics. Now, inside mechanics, in fact, before we get into all of this, we are going to look at some basic mathematics, right? Especially even to start off with mechanics, there are some some aspects of maths which we can't. In fact, other students can't wait to learn. They learn sometime in the 11th and 12th. They can't wait to learn, so they learn in the beginning. I'm talking about the engineering students. But for you guys, since you won't even be having maths as such as a subject, right? This is all the more important that we do this right at the beginning. It's impossible to start mechanics without doing a couple of chapters of maths, basic maths. So those chapters, two of those chapters is what we're going to start with. The first one is called as vectors, and the other one is calculus. Okay, so vectors and calculus. These are two chapters we're going to look at in detail. Vectors and calculus. All right. So today we'll be starting with vectors. With regards to what textbooks you need. So I'm sure you got a list of a lot of textbooks for physics. Honestly, according to me, for the time being, I would say that I don't fully agree with the list. I don't fully think that you really need all textbooks in that list. Okay. These are a bunch of good textbooks that are out there. One is the H.C. Verma. Okay. One is H.C. Verma. Another is, so this is the name of the author. Even if you just type H.C. Verma, you will directly be given you'll come across the book. So you have H.C. Verma, which is 2 volumes. You may need both volumes. You can start with volume 1 though. And there's another book called as D.C. Pandey. Again, that's the name of the author. D.C. Pandey is the name of the author. So these are a bunch of good books. Another, standard recommended book is the NCERT, because at the end of the day, your exam is based on the NCERT. So then NCERT becomes another suggestion. NCERT has 11 standard books, 12 standard books, and even in 11th and 12th, they have 2 volumes each. So 11th volume 1, 11th volume 2, and then similarly for 12th. you don't need to go beyond these books. You don't need all three books. You don't need to read from all three books. In fact, from our side, we're going to try teaching in such a way that uh, you, for theory at least, you won't even need the books. We'll try to make it complete from our side so that you don't have to refer to these books for theory, but we may use some of these books to solve sums. And apart from that, you have a booklet as well. Okay. Um, Now the thing with multiple books is, if you're wise and you realize here a book है, that doesn't mean मुझे पढ़ना ही है उससे. I can find a book which suits me, right? If you are clear कि अच्छा, just because the book is there, that doesn't mean I have to solve it. I have to see which is benefiting me, and that I will solve. If you are wise in that respect, if you have that kind of understanding, then there's no harm in buying a couple of books and checking it out, because different people like different styles of books. Some people like books where all formulas are nicely written and boxed. Some people like books where there is more, where there's more literature, अच्छा story की तरह लिखा है, चीजें derive करके दिया है. Some people like those kind of books. All right, so you may never know which kind of book you prefer to study from. Even sometimes just the color of the font and all makes people biased towards one book more than the other. So I would say that you can, for the first, you can just maybe try to buy H.C. Verma Volume 1, see how you like that. Or you can take D.C. Pandey, if you're wondering which. D.C. Pandey has individual books for all the sections. So if you're wondering where we are actually at mechanics. Okay? So basic mathematics, they normally club it with the mechanics book. So if you want to check out DC Pandey, you can check out that. DC Pandey, I think, has a medical, DC Pandey has a medical version as well. So you can try that out. As for the soft copy of all your booklets, all right, so I'm sure you all are, I'll in fact send a message to your center managers to send you the soft copies. Okay, so your soft copies are always with your center manager. Sometimes just asking your center manager, you can directly, they'll give you the book. But for now, in fact, today after class, I'll message the center managers and inform them to send you your vectors booklet. Okay. And okay, so H.C. Verma, acha, you're asking about whether these books are objective or subjective. H.C. Verma is subjective. H.C. Verma is subjective. It's one of the oldest, most standard books for physics. So it's subjective, but it's still good. It'll still build your concepts. DC Pandey is, has a combination of objective and subjective questions. So maybe I have a hunch you may like DC Pandey more. One of you is asking about Arihant. This is Arihant. DC Pandey is Arihant. So Arihant is the publication, and DC Pandey is the name of the author. So you can check it out. Check out DC Pandey Mechanics and see if that suits you. Okay, these are reference books. In fact, for the beginning, for vectors and calculus, we are gonna just solve questions from a booklet. So I won't be giving you questions from anywhere else. Okay, vectors and calculus, we'll just solve questions from the booklet for now. For previous year questions, some of you are asking, what about the previous year questions? वो कहाँ पे मिलेगा? Previous year questions तुम्हें booklet में मिलेगा. Booklet will have a section for the previous year questions, and if I'm not wrong, DC Pandey में भी हो सकता है, but booklet में definitely होगा, so you don't need to worry about it. Okay, cool. Clear with the instructions. All right, so I'm just gonna with this, let's get started with vectors. All right, so this is our first page. See? So I'm going to ask you, let's start with this basic idea. By the way, all these notes are already pre-written. I'll maybe use a highlighter to highlight and refer to what I'm reading out. These I've made this the previous time. If there are any changes, I'll update those changes. But If you guys want to make notes, as I said, if you want to make, you can make as soon as I open the page. I'll take sufficient time to read through the page. So hopefully by the time I'm done reading, you can finish writing. Nonetheless, if you still want me to wait before I go to the next page, just type wait and I'll wait. Okay. All right. The first kind of question we ask is 2 plus 2 always going to be equal to 4 for all physical quantities? Very nice, Kainat. I hope I'm pronouncing it right. What are the other thing? Is 2 plus 2 always going to give me 4? It's the kind of question that is making people a little wary and they're saying no. Kuch to galat hoga isliye. Very nice. Okay. In fact, you guys you're all nailing it. 2 plus 2. Some are saying yes. So 2 plus 2 is 4 in certain situations. Like we know for number of apples, 2 apples plus 2 apples is 4 apples. Right? We know for time, something like time, 2 seconds plus 2 seconds is 4 seconds. Right? But for something like force, for very nice. So something like force, 2 Newton and 2 Newton need not always add to 4 Newton. Right? Force is some kind of quantity where, yes, it seems like this kind of addition seems to depend on direction. What you guys are talking about, same direction, opposite direction. What happens when I try to push a car with a force of 2 Newton and I add another force of 2 Newton and I add it in the same direction? If two people are trying to push the car in the forward direction, the net force that we get on the car, we understand that our forces are adding up. So we are expecting that somehow the net force on that car should be 4 Newton, aage ki taraf, to the right. Whereas on the other hand, we have a feeling that if these two people were to push the car in opposite directions, ek aage ki taraf, ek piche ki taraf, we don't need to know how to add forces yet, but we expect this answer to be 0. Logically, from day-to-day observation, two people pushing in opposite directions with the exact same force, we expect the answer to be 0. Yes, Arushi, that's also right. So in fact, all of you were saying that when the forces are in opposite directions, their sum is going to add up to 0. Now, what are we realizing with this? We're realizing that force is some kind of quantity, jiske liye 2 plus 2 is not always 4. In fact, force is some kind of quantity, jiske liye addition seems to depend on the direction. Addition somehow seems to depend on the direction. And therefore, you'll in fact find that force is not the only such quantity. So one of you saying, why isn't this 2 minus 2? So understand this, minus means removing. Okay, minus means removing. When I say 2 plus 2 over here, I am implying that in addition to this force that I've highlighted, I'm adding another force. Okay, I'm adding another force. Now, what you guys are saying, you're digging into what's going to happen a little later, and you're saying you're logically explaining why this should add to 0. That's fine. That's good. But do you still understand that this is an addition? This is forces in opposite directions, but I'm adding, I'm combining. Adding means combining. I'm combining two opposite forces, and that's ending up that's resulting in a 0 force. Okay, that's resulting in 0 effect. All right. So Manasvi, Kainat, Soham, you're all right. You're correct, and we're going to see that why this ends up behaving like subtraction, because as you can see, 2 and 2 are cancelling out. But technically, what is this? This is the addition of two forces, the combination of two forces. And then there is more. Matlab perfect 0 bhi nahi. You know, there is something which is beyond 2 plus 2 and 2 minus 2. What if I push the car with forces like this? 2 Newton, 2 Newton. Do I expect to get 4? Do I expect to get 0? Or do I expect to get something else? Huh? Something else only. So it's not something ki sirf 4 or 0 mein result hoga. This is something weird. We know it's not as much as 4. We know it's not perfectly cancelling out, so it's not 0, but it's going to result in something else. So force is some different kind of quantity where addition seems to depend on direction. And there are many more such quantities which behave like force. So what are these quantities called? Let's have a look at that. I think you guys know already. These quantities are called as vectors. Okay, these quantities are called as vectors. So can I move to the next page? If anyone wants me to stay on this page, please say wait. Okay. All right. So let's see how a vector is defined as. Okay. So a given quantity, now we may have learned, some of you may have learned vectors in school, but you may have not had the complete definition. Okay, so let's maybe unlearn the short definition and learn the full complete definition. So what is the definition? What is the criteria for something to be called as a vector? A given quantity is a vector if it obeys all three of the following conditions. All three of the following. एक सही होना, दो सही होना काफी नहीं है, तीनों कंडीशन जो नीचे है सही होना चाहिए. All three. Okay. If it does not follow all three, any quantity failing to follow the above three criteria will be called a scalar. Okay. So whatever is not a vector is going to then be a scalar in simple terms. Can I please zoom in? Yeah. Is that enough? All right. Okay. So any quantity which fails in the above three criteria will be called a scalar. Any quantity failing in the above three criteria will be called a scalar. Okay. Now, what are these three criteria? The first thing is the vector must have magnitude as well as direction. Okay, what is magnitude? Magnitude is a number followed by a unit, which tells us how large or how small the physical quantity is. So magnitude is always a number followed by a unit. Like for instance, in the previous case, what is magnitude of the force applied on the car? It was not just 2, because 2 what? It was 2 Newton. 2 Newton was the magnitude. Magnitude is a number followed by the unit. When you talk about time, okay? So if you make someone wait and I ask you how long did you make him wait, you can't just say 5. You also need to specify the unit. So did you make him wait 5 seconds or did you make him wait 5 hours? Two very different things. All right. So to describe how large or how small that quantity is, you need to give a number as well as a unit wherever necessary. So that number plus the unit becomes magnitude. Okay. Now a vector, for a vector, you should have this magnitude, but you should also have a sense of direction, which you know for time. I mean, you don't need to really specify the direction. If somebody asks like how long did you wait, you just have to say 5 hours or 5 seconds. You don't need the sense of direction to specify. All right. Similarly, how many apples did you eat? I ate 10 apples. Right? You don't talk about any sense of direction over there. When you talk about force, as we saw in the previous case, right? If I'm pushing a car and I ask, I mean, why would I talk like this? I don't know. But if I ask my friend to come and help me by applying a force of 2 Newton, right? Now, unless he is having basic common sense, I'll also need to specify the direction. If he's a robot, I need to say push with 2 Newton in the same direction I am pushing, because direction matters. Pushes in any other direction, the final effect is going to be different. So vectors are those quantities jiska full description needs magnitude as well as direction. Right? Even when they talk about wind ka velocity, we always, to understand the entire velocity, to understand how wind is really blowing, we talk about its speed, how quickly it's blowing, but then we also give the direction. It's blowing from northwest, it's blowing from east, it's blowing from south. Yeah? So direction, wherever direction matters and magnitude matters, those quantities are called vectors. But that's not enough. Sometimes a school stop over there as the definition of vectors. That is not enough. That's one of the conditions, one of the most important conditions, but still one of the conditions. There are two more conditions that vectors must obey. The second condition they should obey is that A plus B should be B plus A. Its addition must be commutative. Its addition must be commutative. Matlab, its addition should be independent of the order in which we are adding them. Okay, so you'll realize that, I mean, you won't see a contradiction in this for a long time, but maybe towards the end of your 11th standard, you will end up seeing one quantity which you don't know yet. You will study that quantity. It seems to have magnitude, it seems to have direction, everything is fine, but it somehow does not obey this condition. Okay, and then you'll realize that that quantity is not a vector. So that's for later. But just remember that this is one important condition. Logical है, A plus B should be B plus A. You know? Third condition that vector should obey is it should obey the laws of vector algebra. The laws of vector algebra. What is the laws of vector algebra? It's something we're going to study in this chapter. Okay, so in this chapter, we're going to study vector algebra. We're going to study how to add vectors, how to subtract vectors. Though the name of that law is going to be, one of those laws is going to be called as triangle law. What is it we will study in this chapter? But whatever that is, a vector must obey those laws. It must add like vectors add. How do vectors add? We don't know yet, but we do know it seems to depend on the direction. 2 same direction is 4, 2 opposite direction is 0. Something which depends on the direction, right? So it needs to add like a vector should add. That is the important condition. The laws of addition you have learned in school, where 2 plus 2 is always 4, 3 plus 5 is always 8. The laws of addition you've learned in school, they are called laws of scalar algebra. Okay, so that's how you add numbers. Any quantity which fails in these three categories is going to be called a scalar. So time, number of apples, they're all scalars. Any number as such by itself is a scalar. Okay, let me know if you want me to wait on this page. We'll go over some examples on the next page. Okay, if you want me to wait, just say wait. All right. So some examples of vectors. Now again, we may have heard some of these terms in school. Okay, but let's just see them now itself. If there's any term you don't know, we'll of course define them. So for instance, time is a scalar quantity, right? Time has no sense of direction. Then between mass and weight, how do you differentiate between mass and weight? Mass is in kg. Mass into gravity is weight. Very nice. Mass has no sense of direction. Fair enough. Okay, so I have a page over here where I'll go over the difference. So maybe I'll just, if you don't know what, some of you seem to know what mass and weight is. If you don't know what mass and weight is, we just go over that. But for now, mass is basically mass is the amount of, matter basically in your body. So mass is what is measured in kg. But then weight is a force. Weight is the force with which the earth pulls you down. Right? So the force of gravity you experience, that is called as weight. Weight is mass into g. Yeah, all that is on the next page. The force with which the earth pulls you, that is weight. So because weight is a force, yes, you're all right. Weight is gravitational force. And because it's a force, I'm so sorry, it comes under the vector category. Because it's a force, it comes under the vector category. All right. Then you have speed and velocity. How are they related? So I mentioned this a little while ago. Speed is just the magnitude of velocity. So when I talked about wind speed, if I say wind is blowing at 55 kilometers per hour, that is the speed. Just the amount, कितना तेजी से जा रहा है, that's the speed. But कितना तेजी से जा रहा है, किस direction में जा रहा है, that entire description is velocity. So velocity is speed along with the direction. Speed with direction is velocity. Speed is only the magnitude of velocity. So 55 kilometers per hour towards north, that is velocity. Only 55 kilometers per hour is your speed. Okay. Then acceleration you're going to find is also a vector. These are all terms we'll of course learn and define. Every term will be defined in due time. Every single term, excluding time and mass. Yeah, rather in fact excluding time. Every other term will be defined over the course of this. But still, you have some idea of this acceleration. At least acceleration due to gravity तुम्हें पता होता है. वो g है, but g का direction भी क्या है? Downwards है ना? So acceleration is actually the rate at which velocity changes. बाद में सीखेंगे, but फिलहाल remember it's a vector. It has magnitude, like g is 9.8 meters per second square, and it's in the downward direction. Okay? It's in the downward direction. Why is current written in a different color? That's a good question. Current is a little tricky. I'll come to that. But between distance and displacement, are you aware that distance is a scalar and displacement is a vector? Okay. I have a slide where I explain what they are as well. I'll go to that slide. But distance is actually the length of the path you cover. Okay, so if you jog along a track, distance is how long you have traveled. And displacement, very nice, it's the change in position of an object. Well, displacement in simple words, ask the question, banda kidhar gaya, kitna dur gaya? Kidhar gaya, kitna dur gaya? Now, some of you have been taught in school that displacement is the shortest distance between 2 points. That's partially correct. That's partially correct. If imagine the length of this path is 4 meters, and this is 2 meters, displacement is not just 2 meters, because 2 meters is only magnitude. Where is the direction? You also need a sense of direction. All right. So yes, Somil, yes. Now you also need a sense of direction. So displacement, the complete description of displacement is 2 meters is direction. Understood? So displacement is, of course, its magnitude is the shortest path. The direction is from start to finish. Because displacement asks the question, ये बंदा कुल मिलके किधर गया? तो कुल मिलके किधर गया कैसे डिफाइन करोगे? सिर्फ 2 मीटर बोलना काफी नहीं है. तो बोलोगे 2 मीटर उस तरफ गया. 2 meter towards right, ultimately guys. That is what displacement is. That also is written on one of the following pages. So you don't need to worry about that. But just again, just explaining briefly. Then you have certain other quantities that you'll learn, stuff like work, stuff like energy. So again, these are scalars. These are just measured in joules. I did 10 joules of work. I spent 10 joules of energy. I supplied 10 joules of heat. Okay, we don't have a sense of direction for these guys. 10 joules of work, 10 joules of energy, 10 joules of heat. Power is rate of doing work, right? Power, these all add like scalars, mind you. 10 joule heat दिया और 10 joule heat दिया, 20 joule heat हो गया, है ना? Power is a scalar. 10 watt of power is consumed. 10 more watt of power is consumed. 20 watts of power is consumed. Charge is a scalar. Okay, charge adds like numbers. 3 coulomb charge and -1 coulomb charge. Add करोगे क्या मिलेगा? 3 coulomb charge -1 coulomb charge. Add करके क्या मिलेगा? Okay, one of these asking how is charge a scalar? So what makes you think it's not a scalar? What makes you think it's not a scalar? Is it because charge can be negative? Acha, you're saying because they have a, shouldn't they have a direction? Cause they move. यार इसमें movement का बात नहीं है. Now one of you saying should they have a direction cause they move? So if they move, what is this? What is the vector then? Once they start moving, the vector quantity is actually velocity. If they move, then either displacement, how much they move, or velocity, how fast they move, where they move, those become the vectors. Charge is just the description of what it is carrying. That is not something which needs to have a sense of direction. Charge is like its name. I mean, that doesn't seem to have a sense of direction. Okay. So charge is 3 coulomb minus 1 coulomb. These are not vector quantities. If you see them moving, you'll say they have velocity, which is a vector. You'll not say the charge is a vector. Okay. And then the second thing is, just because negative charge hai, that doesn't mean it's a vector. Please understand, numbers are positive and negative. You must have learned in third standard. So don't think scalars have to be positive. All right, scalars are numbers. Numbers can be positive, numbers can be negative. If I combine them, I should get the result I get when I add 3 and minus 1. What have I learned in school? Everything I've learned in school is scalar algebra. 3 and minus 1 adds to 2. So when I combine 3 coulomb and minus 1 coulomb, I get 2 coulomb. Charge adds like a scalar. It does not add like vector. There's no sense of direction. कैसे भी charge को move करो, 3 and minus 1 को club करोगे, neutralize होके 2 ही मिलेगा. Right? So charge is therefore always a scalar. I hope that clears it out. I'll mention current in a while, but just remember current is a scalar. We'll talk about that. And finally, something called as linear momentum. Linear momentum. Yes, any acha, koi bol raha, can rest of the scalars also be negative? I mean, scalars in general can be negative. You will find ki with speed, with mass, with time, with distance, in these places, negative makes no sense technically. So that's why for the way they are defined, you will learn ki technically negative makes no sense. But I mean, at least stuff like work, energy and all, these can be negative, which you learn when we study work, energy and all. Okay. Linear momentum. Linear momentum is mass into velocity. Just remember that. Linear momentum, new term, mass times velocity. So it's mass times your velocity vector. Okay, so if my velocity vector is 3 meters per second and my mass is 2 kg, then my linear momentum becomes 6 kg meter per second. So it has the same direction as velocity. Therefore, it is a vector. Yeah, these are just a few examples. I'll clarify some of the points of discussion over here, like for instance, mass and weight, current, speed, and distance and direction. Let's go over weight and mass. So weight, as you guys know, it's the force of gravity with which a planet pulls us. There's a force of gravity with which a planet pulls us. So if you have your mass m, weight is always m times g. Weight is always mg. Okay. If you're on the surface of the earth, for instance, if you're a particular mass m on the surface of the earth, weight is mg. You will learn later on that when you go up and go above the surface of the earth, or you go into the surface of the earth, g ka value changes. You learn all this in gravitation. It's going to be quite interesting. But for now, g on the surface of the earth at least is 9.8 meters per second square, or 10 meters per second square. Okay. Mass is what your weighing machine tells you. In fact, what people refer to as weight in English, that's not wrong. In English, it's fine. It's a synonym. In English, jo log weight bolte hain, in physics, the technical term for that is mass. As you guys are well aware, I'm assuming. So in physics, the most technical term for what is measured in kilograms, what your weighing machine tells you, that is actually mass. Okay. And when you multiply that with g and you give it a direction, like gravity pulls us downwards, so then that becomes weight. So weight in this case for a 65 kg fellow will be 650 Newton downward. Complete idea will be 650 Newton downward. That is going to be weight. So you guys knew that, but if anyone wants me to weight WAIT on this page, just let me know. As I'll go to the next one. Nobody's saying weight. All right. बोलना तो बोल दो, okay? Don't feel shy. Velocity and speed. As I said, velocity is speed with direction. Speed, for instance, will just be 60 kilometers per hour. Imagine speed of a vehicle will be 60 kilometers per hour. But velocity will tell कि vehicle किधर जा रहा है, कितना तेजी से जा रहा है. So it will say 60 kilometers per hour due north. So when you combine the direction, it becomes velocity. Scalar के साथ direction club करोगे तो vector बन जाता है. ठीक है? फिर distance and displacement. As you can see in this path, I mentioned distance is actually the length of the path. So the length of the gray path is distance. Displacement is a vector. It's not just the shortest distance from start to finish. वो सही है, but incomplete है. Shortest distance from start to finish सिर्फ magnitude बताएगा. Displacement vector होने के कारण direction भी हमें specify करना है. So best way to answer this is displacement is the vector going from start to finish. Okay, now don't worry about writing that down. That again comes in one of the that'll again I'll give you the proper definition sometime later in this chapter. But for now, just remember displacement is the vector going from start to finish. So that's how you get its magnitude and you get its direction. It asks the question, banda kidhar gaya? Banda idhar gaya, itna gaya. All right. Anyone wants me to wait on this page? All right. Current. Okay, the big question. Why is what is the deal with current? If you remember, I had placed it under the scalar category. So current is a weird kind of scalar. You won't find it weird later on, but just at the beginning, you may think that current seems to have a sense of direction. And when I talk about current in a wire, we know that it has magnitude 5 amperes, right? And it can also have a sense of direction because I can say the current is going towards right in this wire, or it's going towards left in this wire. So just magnitude is not enough. In fact, the direction also makes a difference. Going towards right, going towards left is going to mean two completely different things, right? So current has magnitude, it has direction. It satisfies the first criteria. Remember, the first criteria was it should have magnitude and direction, but it does not satisfy the third criteria. The third criteria was that it should follow this weird thing called as triangle law. Now we don't know triangle law yet, but we know it is some law by which vectors are added. We know that when I added 2 Newton and 2 Newton, we were getting 0. It's some law where 2 Newton in opposite direction gives 0. It is some law where addition seems to depend on direction of the quantities. Whether they are in the same direction, opposite direction. It seems to depend on the direction. But in the case of current, whenever I have like these two wires meeting and becoming one, and whenever I have currents 2 amperes and 2 amperes coming in, I'm always going to get 4. 2 amperes and 2 amperes is not going to become 0. Because this is like flow of water. 2 amperes means यहाँ से 2 coulomb charge आ रहा है, वहां से 2 coulomb charge आ रहा है, वो मिलके इधर 4 coulomb charge जाना चाहिए, है ना? So current is always going to add up like a scalar. It does not matter what is the angle between these directions. These wires could have been parallel. These wires could have been at any random 90 degrees, 60 degrees, or they can even be opposite. 2 plus 2 is always going to be 4. So we know that when 2 plus 2 adds to 4, that is not the behavior of a vector quantity. So current does not add like a vector. It doesn't obey the third condition. And because it doesn't obey the third condition, because it adds like a number adds, it is a scalar quantity. it had to obey all three conditions for it to be called a vector quantity. If it doesn't obey the three conditions, it's going to be a scalar. All right. Any doubt in this? Okay. Anyone wants me to wait? Let me know. Wow, looks like you guys are all fast in writing. Okay, please don't hesitate to say wait if you need. Let me just zoom in. This is page 7. Okay, representation of vectors. All right, so now we're getting into vectors and it's algebra. How do I represent vectors? So the idea is vectors are represented using arrows. Okay. The direction of the arrow gives the direction of the vector. This is the most logical, intuitive thing. I draw a vector like this, you understand it's going towards the right. I draw a vector like this, you understand it's going in that kind of direction. All right, so the direction of the vector, the direction of the arrow gives the direction of the vector. No problem. The length of the arrow is taken proportional to the magnitude of the vector. अब इसका मतलब क्या है? मतलब लेंथ इज प्रोपोर्शनल टू मैग्नीट्यूड, मतलब जितना लंबा उतना ज्यादा मैग्नीट्यूड रिप्रेजेंट करेंगे. फॉर इंस्टेंस, if I draw a 5 Newton vector like this and I take up 2 centimeters length to draw that line, when I draw a 10 Newton vector, to draw this line, technically how long should this line be? It should be 4 centimeters long. Because if 5 Newton took 2 centimeters, if I double the magnitude, I should also double the length. So 10 Newton should take 4 centimeters. मतलब length is proportional to magnitude. अब ये तुम्हें कभी ऐसा scale use करके करना नहीं है. This is a theoretical idea. ठीक है? Theoretically, it has to be double. तुम ऐसे roughly draw कर सकते हो अपने books में, but just understand that theoretically it has to be double. Okay. Now this is fine. Okay, I can represent any vector in the plane of my screen by drawing these kind of directions. But what if I want to represent a vector that is coming out of the plane of my screen? Like in a 3D movie, if somebody fires an arrow towards you and for some reason you want to calculate ki arrow तुम्हारे तरफ कितना तेजी से आ रहा है, then right, then how do you represent that velocity of that arrow? Or if I am pushing my screen, if you're touching your screen and you want to measure with what force you touch your screen, then of course you can write the magnitude of the force, but how do I represent the direction? It's a direction going into the screen. Very nice, Varun. So you represent them by making these circles. Okay. So if I want to represent a vector going away from us, that is into the plane of the screen that is in front of me, then I will represent it by an X with a circle around it. And magnitude I'll write somewhere next to it. So for instance, this represents a force, 3 Newton force going into the screen right now. Okay. What is the logic behind this? So as we know, vectors are represented as arrows. And if you were to fire an arrow, what you would see if the arrow was going away from you would be the feathers at the end of the arrow, at the tail of the arrow. And those feathers you might have seen in cartoons and all those. I mean, the back view of an arrow looks like an X because of those feathers. So that is the logic behind this representation. So 3 Newton with an X and a circle, remember that means into the plane, away from you, away from you. And a vector coming towards us, that is coming out of the plane. Remember I said in a 3D movie, somebody fires something at you, maybe a bullet, and you're trying to calculate the velocity of that bullet. How will I represent that? So I'm going to represent that as with a dot and a circle around it, and I'll write the magnitude next to it. So this could represent the velocity of that bullet. Again, what is the logic behind the circle and the dot? this is what you will see if the arrow were to be fired towards you. If a vector comes towards you, an arrow is coming towards you, the first thing you'll see is the tip of the arrow, which looks like a sharp point. So that's the logic behind the dot representing a vector coming towards you and an X representing the vector going away from you. Got it? जो भी magnitude है उसके बगल में लिख लो. So now we can effortlessly represent all our vectors. Any doubt in this? No? Anyone wants me to wait? Let me know. Okay, I'll wait. Finally, somebody saying wait. Yes, Smriti Rupa, yes. I mean, this is what we'll technically, so one of you saying, sir, is this what we call as the Z axis? तो अब x, y, z ऐसा फिक्स नहीं होता है ना? तुम अपने मर्जी से x, y, z का डायरेक्शन कुछ भी टेक्निकली ले सकते हो. People who can take z like this, x like this and so on. But मतलब normally ऐसा होता है कि people take this as the x axis, this is the y axis, and then by default then the vector coming out of the plane towards you becomes your z axis. So yes, in that kind of normal convention, these are along the z axis. Okay, I think all those who said wait, I think you're saying if you're done, let me know. Will the direction of the vector depend on the position of the person? The okay. The answer is no. The direction of a vector is its own thing. It won't depend on the. Actually, what you're saying depends on the context. Like, for instance, something like velocity will not depend on the position of a person. If I say my wind is blowing with a speed of 5 meters per second towards east, whether I'm over here or whether I'm over here, I should still expect to see that the wind's velocity is 5 meters per second towards east. That's a property of that wind. But then there's going to be one very specific term. In fact, most terms will not depend on position. Only one very specific term called as position vector, जो बाद में हम define करेंगे, that depends on position. Position vector asks the question कि ये object तुम्हारे respect में किधर है. अगर तुम ऑब्जेक्ट के नीचे रहोगे तुम बोलोगे ऑब्जेक्ट मेरे ऊपर 1 मीटर है, तो फिर वो ऑब्जेक्ट का पोजीशन वेक्टर 1 मीटर अपवर्ड्स होता है. बट अगर तुम ऑब्जेक्ट के साइड में हो रहोगे तो तुम बोलोगे यार ऑब्जेक्ट मेरे लेफ्ट की तरफ और इज दिस राइट की तरफ 2 मीटर दूर है ना. सो द पोजीशन ऑफ दैट ऑब्जेक्ट एज सीन बाय यू चेंजेस if your position changes, but that's just one specific vector. वो भी because उसका definition वैसा है. ठीक है. But to basically answer your question, magnitude and direction of a vector is something which is that vectors, and that won't for almost all vectors that except position vector, that won't change if you change your position. And for those who got scared hearing the word position vector, please don't worry, we'll learn about that in this chapter itself, so don't worry. But I hope I answered your doubt, whoever asked that. Okay, let me know. Now symbols. So these are the symbols that we use for vectors. So the symbol for a vector, the symbols used for a vector can be any alphabet, A, B, C, X, Y, Z, school में use करते थे, maths में. So it can be any alphabet, but it should be written in a specific way. So what we should do is, you'll either write the alphabet with a bar over it. Okay, so you can see this, either you'll see a एक second, let me just check this down. So one of these asking ki, if I apply forces in opposite directions on any object, then they should cancel out. Why shouldn't, why does it happen that the object breaks? So the idea is ki, yeah, they should cancel out has to do with what a force tries to do. What does a force try to do? Force tries to move an object, accelerate a stationary object. Okay, that will cancel out. Force ka kaam will cancel out. Okay, so I mean, this force was trying to move the object towards the right. This one was trying to move the object towards the left. That cancels out. That doesn't mean ki applying these forces is as good as doing nothing. Applying these forces can still compress this object. You can still shrink its size by trying to squeeze it inwards. You can, if force is not perfect, you may even end up breaking the object. है ना? So cancel उस respect में force के काम के हिसाब से वो cancel हो जाता है. Force का काम था move कराना, वो move नहीं होगा. That is the answer. Newton's second law. Force tries to bring acceleration. Force cancel हो रहा है, मतलब acceleration नहीं होगा. But ये बाकी सब हो सकता है. You try to push it inwards, you will end up compressing the object. Try to pull it outwards, you'll end up extending the object. वो effect रहेगा. Okay. Now the symbols for a vector can be any alphabet written with a bar over it. So what does the bar look like? Let me just zoom in to show you that. It can be basically any horizontal line written directly above the alphabet. Sometimes some textbooks are a little bit more fancy, so they may draw the line with a double arrow. I mean, draw the line with an arrow like that, or maybe draw the line with just, just the top part of the arrow. It's called like a fish hook symbol. You don't need to know the name. Basically, all of them, we'll call it as bar. So whenever you write an alphabet with some kind of line over it, fancy or simple, we'll refer to that as a bar. Okay, so it's read as a bar. A bar. This is how you represent vectors. Okay, this is how vectors are represented. The second option is, sometimes while typing and all, we don't have access to all fancy symbols. So the second option is to write it in bold. When the same alphabet is written in bold, it also again represents a vector. So ya to alphabet in bold, ya alphabet in bar. These are the symbols that you use for vectors. Okay. Now, यही alphabet को बिना bar और बिना bold अगर वापस लिखोगे, when you use the same alphabet again without the bar and without the bold, एक second, then it represents the corresponding magnitude of the vector. Okay, so let me explain that. One of you is asking, sir, does the direction of the arrow depend on the vector? I think you're referring to this. No, that's just the symbol. ऐसा नहीं कि upward जाने वाले vector के लिए तो मैं ऐसा कुछ symbol बनाऊंगा. That's just a symbol. It's just what is available for the person typing, उसके हिसाब से होता है. Ultimately, it should look like a line above the alphabet. Now, when the same alphabet is written without these bars or written without that bold, then it represents the corresponding magnitude of the vector. Okay, so let me or let me read the next line as well, then I'll explain it. Or when the same alphabet is used with a mod sign around it, it represents the magnitude of the vector. Okay, so first and foremost, I'll explain all of that. First and foremost, if a bar is 5 Newton towards the right, so ये vector has two parts, the direction which is right and magnitude which is 5 Newton. अगर मुझे इस vector का magnitude के बारे में बात करना है, then instead of writing a long line magnitude equal to 5 Newton, how do I represent the magnitude of a bar? I can represent it in two ways. I can either write the same alphabet without the bar. Now, when I write the same alphabet without the bar, automatically I end up talking about just the magnitude of this vector. So when I write it without the bar, I'm talking about 5 Newton. I've removed the direction. So just A then will represent 5 Newton. This is one symbol. Okay. And this one is tricky. I mean, people tend to miss this. The other symbol, which is very obvious, sorry, The other symbol, which is very obvious, very clear, is if I put a mod sign around it. So mod is basically these two vertical lines that you will put on either side of a vector. So if you put the mod symbol around it, then that also removes the direction and it makes it 5 Newton. You remove the direction by placing a mod symbol. So these are two ways by which you can represent the magnitude of a vector. Okay. When you put the mod symbol, please ensure that the bar is still there. The bar or the bold is still there. So giving you one more example, if I used a bold, okay, to represent 3 meters per second upward, and I want to talk about the magnitude, then just a normal A immediately represents the magnitude. And the same A bold with a mod symbol around it again represents the magnitude. Okay? Understood how we can talk about the magnitude? Either you put a mod symbol, that is, you put two vertical lines on either side of that vector symbol, like this or this. That's one option. Or you remove that distinguishing factor. You remove the bar or you remove the bold and just write the alphabet, you end up talking about magnitude. And so this, by the way, this is velocity. This is the speed. A bold was velocity, and just A is going to be your speed. The speed is the magnitude of velocity. Any doubts in this page? And let me know if you want me to wait or anything. Okay. So when we represent the vectors, we have to put the direction arrow like upwards next to 3 meters per second. Yes. Yeah, I mean, you need to represent the direction as well, right? So when I am defining a vector, I need to either draw the direction, or maybe I will say up or down or north or south, anything which can represent the direction. Later on, you'll learn there are more ways of representing the direction. For now, we are representing it with arrows, and okay, later we'll study more ways. But for now, we'll either draw arrows or we'll say up, down, north, south, east, west. Any other doubts? Yes, yes, Achha, bold. Yeah, I mean, both of these are speed. Both of these are the same, by the way. Huh? Both are same. These are just two different ways of representing the magnitude. Both are the same. Both represent speed in this context. All right. Let me tell you a little bit more about mod or modulus or the absolute value function. These are different names of the same thing. Again, mod is the short form for modulus. Can I please scroll? Can I please scroll up? Scroll up. Do you mean go to the previous page? Did you mean this? Let me know when you're done. Whoever brought me here, जब हो गया तब बता दो. In the meanwhile, for the rest, have you seen this mod symbol before? In any other context? You know what it does? In programming. Nee, what does it do for numbers? It seems to tell the absolute value of a number. It makes a number positive from negative. Basically removes the sign. Very nice. That's all right. Yes. Okay. Makes the number positive. All right. Yes, Girish, that's also right. So I hope you're done with this page. Hope. Okay. Modulus or mod or absolute value function, they're all, I mean, names the same function and same symbol. These, for a vector, it does what we just saw. It removes the direction and gives the magnitude. तो वेक्टर के लिए mod सिंबल करेगा क्या? डायरेक्शन हटाएगा. ठीक है, डायरेक्शन हटाएगा. बट स्केलर के लिए क्या करता है? स्केलर के लिए वो माइनस साइन हटा देता है, अगर है तो. अगर माइनस साइन है तो हटा देता है. सिंपल. तो mod of 3 is 3. Scalar, by the way, please remember, I don't know from where people pick this up. Scalars, some people think, can only be positive. That's absolutely wrong. Scalar is a number. Numbers are scalars. Sorry, numbers are scalars. Numbers are positive and negative. Okay. So scalar can be positive or negative. When you put the mod around a scalar, it removes the minus sign. So mod 3 is 3. Mod of minus 2 is 2. That is the job of mod for a scalar. क्या है? Minus sign हटाना. What is the job of mod for a vector? Direction हटाना. Okay, so example, 5 Newton towards right, वो बस 5 Newton report करेगा, है ना? And they say, if for instance a bar is 5 Newton towards right, mod a bar मतलब सिर्फ 5 Newton. It removes the direction of the vector. What it returns is the magnitude of the vector. And please bear in mind, the magnitude of a vector is always positive. The magnitude of a vector is always positive. Okay, so है ना, for instance displacement, somebody says बंदा किधर गया, तुम बोलोगे 2 meters towards west. You will not say minus 2 meters towards east. It means the same thing, and later we'll see कि this actually means the same thing, but ऐसा बोलेगा कोई नहीं ना. We are not going to, if there's one way of talking about this vector, we'll say 2 meters towards west. Okay? We won't say minus 2 meters towards east. You can think of it as minus 2 meters towards east if you want to confuse yourself. I mean, you won't confuse yourself, but you can think of it like that. But otherwise, 2 meters towards west, vector ka magnitude is always positive. It's how much and in what direction. How much in what direction. There's never a case jab vector ka magnitude negative hoga. So in a way, if you can see, the absolute value function always returns something positive. जो भी करता है हमेशा कुछ तो पॉजिटिव ही रिटर्न करता है. स्केलर का नेगेटिव साइन हटा देता है एंड वेक्टर का डायरेक्शन हटा के मैग्नीट्यूड रिटर्न करता है. मैग्नीट्यूड एनीवेज पॉजिटिव. ओके, एनी डाउट्स? Let me know if you want me to stay on this page. Can acceleration be negative? No. So again, no vector is technically negative. And just hold on to that. I mean, I think the way I understand from what context you're saying, can acceleration be negative? You're referring to what you have done in kinematics, but with time you'll understand what that actually means when you say acceleration is negative. Actually, क्या होता है जब, just to give you a brief explanation for that, वो acceleration actually negative नहीं होता है. जैसे मान लो तुम गाड़ी चला रहे हो, है ना, एंड कोई बोल रहा है कि in school maybe you must have learned retardation मतलब negative acceleration and all. They are missing, they're not telling you the complete thing. Like for instance, if your car is moving in that direction and your acceleration is 2 meters per second square in the backward direction, meaning you're slowing down. Then when we say कि a is minus 2, that's just a shortcut. तो है ना, that does not mean कि the vector negative है, या it does not mean कि vector का magnitude negative है. this just means कि हम by default बोल रहे हैं कि आगे की तरफ acceleration कितना है. So a 2 meter per second square acceleration in the backward direction is like a minus 2 meter per second square acceleration in the forward direction. And इसलिए हम आगे के डायरेक्शन में एक्सेलरेशन का बात करके हम बोलते हैं -2 है. समझ में आया? It has to do with that. It has to do with components, and it has to do with some ideas which we are going to learn in this chapter. So I would say hold on to that. But this is just a brief idea. When we are talking about A being negative, we are not talking about the exact vector and its magnitude. We are in a way talking about its net effect in the forward direction. तो पीछे की तरफ 2 है, मतलब आगे की तरफ -2 की तरह है, इसलिए बोलते थे कि नेगेटिव है. Nothing wrong in that, but just understand that the magnitude of a vector can never be negative. One of you saying, what will mod 2 be? Mod 2 is 2. Mod 2 is 2. वो माइनस साइन है तो निकालेगा, नहीं है तो वैसा का वैसा ही रखेगा. Okay, and one last. Sir, if force is applied in the east direction, then how can its magnitude not be negative? If a force is applied towards east, that's its magnitude. How do you see that becoming negative? Girish, no. Girish, I would say you hold on to when we study kinematics. It'll all, in fact, it'll all fall into place. You just hold on to those things. Right? Magnitude of a vector as such will always be positive. Yeah, so I see we are almost reaching the end, but before all that, let me just close with just a sec. Let me give you a sample question. Okay? This is where the symbols matter. If you're thinking, yeah, symbols ka kya big deal hai? Why did we spend so much time? This is where the symbols matter. This is what students, even after 1 year, mess up while reading a question on vectors. मान लो सवाल ने तुम्हें ऐसा दिया कि A bar is 2 Newton towards right, B bar is 2 Newton towards left, and they're asking you question 1, question 2. Okay, read the 2 questions and let me know the answers. Bold A दिया है, bold B दिया है, इन दोनों का आंसर क्या होगा? Very nice, Varun, Kenath, Aliza, Suraj. Oh, that's very fast. Soham, Kansha, Molly, Ishan. Okay, basically everyone who has answered, I think you've answered correctly. Okay. Now you've answered it correctly over here. Don't ever forget this. Later on, while reading a question, be that attentive to note कि यार एक चीज bold में लिखा है, दूसरा चीज bold में नहीं लिखा है. I always feel that if the bar is used, things are a little bit more obvious. If the bar is used, if things are in bold, that's where it's a little tricky to. The bar is very, you easily spot कि that's a vector. When it's in bold, वहाँ पे थोड़ा गड़बड़ हो सकता है. यहाँ पे this symbol where we remove the bar or we remove the bold, that is also little difficult to spot. That also sometimes students miss. Had I put something like this in this context, you would have not missed it. You would have directly realized, acha, this is magnitude of A plus magnitude of B. But if I don't write that mod sign and I just remove the bar, it's a little bit more subtle. The difference in these 2 questions is, as I think all of you have spotted, the first one is a vector addition. This is bold A plus bold B. Malam, this is vector A plus vector B. Okay, matlab this is 2 Newton towards right plus 2 Newton towards left, which, as we saw in the beginning, logically adds up to 0 Newton. On the other hand, the second one, this is very subtle. Mod डाला है तो तुम्हारे लिए अच्छा है, but mod वगैरह simple use नहीं किया, बस bold या bar हटा दिया, then this is subtle. But you need to realize this is no longer vector A. This is only magnitude of vector A. This is only magnitude of vector B. Well, this is 2 Newton and 2 Newton. Yeah. This is actually mod bold A plus mod bold B. This is 2 Newton plus 2 Newton. These are now not vectors. These are now not vectors. These are only scalars. So the addition of scalars, you just add them up like numbers. 2 plus 2, 4. Okay? 4 Newton is your total force in this case. यहाँ पे हम, this is just the addition of the magnitude. So 2 plus 2, 4. Okay? No direction wala addition. I hope everyone got that. One of you is asking, what if one is in bold and one is in, what if I add this and this? The answer is they won't ask you that. You can't add a vector to a scalar. That kind of addition is not defined. I can't add time to money or time to force. I can't add two different quantities. So you can never add a vector to a scalar. You can only add a vector to a vector and a scalar to a scalar. All right, clear? So we'll stop over here. And yes, so the H.C. Verma's, so again, the textbooks, as I mentioned, H.C. Verma has only one textbook. Same for IT, same for NEET. H.C. Verma is slightly tougher, but it does have good questions to help you. I mean, it has structured questions. So certain chapters you can refer to that. It'll maybe slightly tough, some of them, but it will definitely help you understand the core concept. DC Pandey has a medical version. You can go for that. You can buy any of the three. There are other books also, as I said. One of you is mentioning MPG. That's also a good book. The idea is different books suit different people. So some people like different fonts, the way theory is presented, the kind of questions. So different books suit different people. There's no harm in purchasing multiple books, at least in the beginning, and just seeing what is going to suit, and then making that decision of, okay, I will continue with this book for the rest of the. Yeah, the H.C. Verma one is totally subjective. It has a few objective questions as well. थोड़े objective questions है, not many, but थोड़े, like a handful of maybe 10-15 objective questions per chapter, but good ones. All right, so that's it. I'll again just on a closing note, I'll send you, first of all, I ask the center managers to give you the booklet. For now, for this chapter, we'll only solve from the booklet exercises, and then I'll also ask I'll ask them to send you the link to the Google Drive. Okay, so where you can access today's lecture recording and all these lecture notes. Lecture notes are all already up, so you can access the recordings and the lecture notes. Okay. All right, thank you. Bye. Bye. Yeah, slide 2. Yeah, those who want to leave can leave. If you have any doubts, you can ask. Ishna, do you have any doubt, or you just completing stuff? Bye. Okay. You done? All right. Bye.